Hello students, I am Trupti Patel from Arihant College of Arts, Commerce and Science. Today we are going to study buffer solution. Buffer solution is defined as a solution which resists drastic changes in pH when a small amount of strong acid or strong base or water is added to it. Students, this is the definition of buffer solution. There are two types of buffer solutions. Acidic buffer, which is used to maintain an acidic pH, and second, basic buffer, which is used to maintain alkaline pH. We are going to study each buffer with example. First one, acidic buffer solution. A solution containing a weak acid and its salt with strong base is called an acidic buffer solution. For example, a solution containing weak acid such as CH3COOH and its salt such as CH3COONA is an acidic buffer solution. pH of acidic buffer is given by the equation. pH is equal to pKa plus log to the base 10 salt divided by acid, where pKa is equal to minus log to the base 10 Ka, and Ka is the dissociation constant of the acid. Second, basic buffer. A solution containing a weak base and its salts with strong acid is called an basic buffer solution. For example, a solution containing weak base such as NH4OH and its salt such as NH4Cl is an basic buffer solution. The pOH of basic buffer is given by pOH is equal to pKb plus log to the base 10 salt divided by base, where pKb is equal to minus log to the base 10 Kb, and Kb is the dissociation constant for the base. Now the above equation are known as Henderson-Hasselbalch equation. Students, both the types of buffers are very easy, and in the first acidic buffer you can see the example and the pH equation is given where Ka is the dissociation constant of the acid. It is acidic buffer and hence we have taken Ka, and in the second it is basic buffer and hence we have taken Kb. Both of them are very easy, and the equation for acidic and basic buffer solutions is known as Henderson-Hasselbalch equation. Now we have studied what is the meaning of buffer, types of buffer solution, how it acts. So that is called as buffer action. Let us consider sodium acetate, acetic acid buffer. Here, sodium acetate is a strong electrolyte which dissociates completely in water, producing large concentrations of acetate ions as follows. So here the equation is given. So CH3COONA. This is the salt, gets dissociated. It's a strong, right? So it dissociates into CH3COO minus plus Na plus ions. Since sodium acetate is a strong electrolyte, it dissociates into acetate ions and sodium ions, as we can see in the reaction. On the other hand, since the acetic acid is a weak acid, the concentrations of undissociated CH3COOH molecules is usually high. If a strong acid is added to this solution, the added H plus ions will be consumed by the conjugate base CH3COO minus present in large concentration. Similarly, if small amount of base is added to the same equation, right, to the same solution, the added OH minus ions will be neutralized by the large concentrations of acetic acid as shown in the following reactions. Right, so the first reaction which we have seen, like this CH3, this is a salt which gives you acetate ions plus sodium ions, right? So here we can see that acetate ions in large concentrations. Now first we have added acid to this solution, so H plus ions, so added acid, H plus ions, so acetate ions plus H plus ions gives you acetic acid. Acetate ions are large in concentration and H plus ions we have added. So acid, H plus ions we are going to get from the acid which we are going to add in that. So that gives you CH3COOH. CH3COOH plus, now if a small amount of base is added, so base means OH minus ions. So CH3COOH plus OH minus ions gives you CH3COO minus ions plus H2O. So CH3COO is in large concentration plus OH minus, this is the base, acid added, gives you CH3COO minus ions. The acid or a base added thus can change the H plus ions or OH minus ions concentrations, and the pH of the buffer remains unchanged. Dilution does not have any effect on pH of buffer. This dilution does not change the ratio also. Now, what are the properties of buffer solution? The pH of a buffer solution does not change appreciably by addition of small amount of, it might be either strong acid or a strong base. The pH will not change. Second, on dilution, if you dilute the solution also, the pH of the buffer solution will not change. or when it is kept for a longer period of time, the pH of buffer solution will not change. So these are the three properties of buffer solutions, and very important, very easy and very important properties of buffer. Now students, we are going to study applications of buffer solution. So where this buffer solution can be used. First, in biochemical system. The pH of blood in our body is to be maintained, right? So that is at 7.36 to 7.42. This is due to the buffer, and you can see in the bracket. A mere change of zero point 0.2 pH units can cause death. The saline solution used for intravenous injection must contain buffer system to maintain the proper pH of the blood. Second, agriculture. The soil gets buffered due to presence of salts such as carbonate, bicarbonate, phosphates, and organic acids. The choice of fertilizers depend upon the pH of soil. Third, industry. Buffers play a very important role in paper industry, dye industry, ink, paint, and even in drug industry. Medicine. Penicillin preparations are stabilized by addition of sodium citrate as a buffer. When citric acid is added to milk of magnesia, the milk of magnesia is MgOH twice. So when citric acid is added to milk of magnesia, magnesium citrate is formed, which is a buffer. Analytical chemistry. In qualitative analysis, a pH of 8 to 10 is required for precipitation of cations of third A group. So when we do the salt analysis, that time this is useful to detect the cations from 3A group. So in qualitative analysis also, buffer solution is important. It is maintained with the use of NH4OH plus NH4Cl buffer solution. So buffer is very important topic, students, and very easy. Thank you.